Ejemplo 7. Example 7. We're going to the word problems now. And again, here, write the word problem down, and then we're going to go ahead and go through it. And yes, I do want you to write the word problem down. Oh my gosh, there's a lot of writing. There's only 3 sentences here. So make sure you write those 3 sentences down, and then you're done. And then we can start working on the problem. So push pause, and let's go. All right. Managers at the Eco Landscaping Company know that a mahogany tree they plant has a survival rate of 90% if cared for properly. 5 mahogany trees are planted. What is the probability that at least 2 trees die? So when we deal with problems like this, when it comes to binomial experiments, there's always going to be 2 scenarios that happen. There's always, you will always have 2 scenarios every time. And let's see if this will change over. Yep. You will always have 2 scenarios. Always. And so here, what are the 2 scenarios that are going on? There's survival rate. If there's surviving, what's the other type of thing that could happen? Dying. So you can either have a survival or dying. So those are going to be our 2 scenarios, survive or die. So we're going to let represent the probability that the trees are surviving. We're going to let D represent the probability that trees are dying. So S, survive, D, die. S, survive, D, die. Because they want to know, the final answer, final question says, or the actual question, what is the probability that at least 2 trees die? So they can either survive or they die. 2 scenarios. And it's not going to be hard whenever you deal with these to figure out what the 2 scenarios are. It should be something that's very simple and easy to figure out. So here, when it comes to these problems, whenever we talk about our 2 scenarios, we always put those 2 letters into the parentheses, and we come up with an binomial, and then figure out what the exponent should be. So here, really quickly, I'm going to throw it over here. I don't know if it's going to pop up. I hope it pops up. Right here. So, like we said, we're going to do S and D. So S plus D. But the thing that we have to deal with here is, what is going to be the exponent? And this time, if you look at the actual problem they gave you here, the exponent is going to be how many there are of what we're talking about. So in other words, in this case, how many trees are there? Because we're talking about mahogany trees. So how many trees are there going to be? There's only 5 of them. 5 trees. So since there's 5 trees, that means our exponent is going to be that number. So when we do it, we're going to do this. S plus D to the 5th power. Because that's the total number of, and it should say trees with the plural. So trees. So the total number is going to go in that spot there. And that is an S right there, trees. Okay, so that's the total number of trees that we're going to deal with. And now here again, I'm going to pull this off to the side. And most of it's going to be covered up because I don't want you to see the rest of that there. And so let's go and work it out. And again here, we're talking about this. So we're going to do what we've been dealing with our combinations and all the good stuff. So 5 is our highest exponent. So that means in our parentheses, we're going to do 5. And for this one, because we're looking for something specific, we're not going to stop. We're going to do all of them. So we're going to get down again to where these 2 numbers double each other. Okay. And then here again, we're going to go ahead and fill in all the stuff because they want to know where at least 2 trees die. And we're going to talk about that specifically. But here again, we do S for the first term. We start off with 5 and then 4, 3, 2, 1, and 0. And then for D, you start with 0 and go all the way up to 5. Okay. So far we're not doing anything. We're not doing anything bad or anything hard. We've been doing the same thing we've been dealing with. So looking at these, just to make sure everybody understands, this means that 5 trees survive and no trees die. This means that 4 trees survive, 1 tree dies. 3 survive here, 2 die. 2 survive, 3 die. 1 survives, 4 dies. 0 survives, and they all die. So that's what we're talking about here. That's what those exponents are talking about. Now, for the problem here, I'm going to bring this big again. They gave us this last part because this is what they want you to find. Let's change it to, let's say, blue. It says, what is the probability that at least 2 trees die? At least 2 trees die. Okay, so if we're talking about at least 2 trees dying, does that mean 2 or less? Does that mean 2? Or does that mean 2 or more trees dying? So, at least 2 trees die. That means 2 or more trees die. So that's what we're looking for, where 2 or more trees are dying. So that means for the letter D, for D, we're going to find where it's 2 or more. And then we're going to deal with just those numbers. So here, this is where D is 2, 3, 4, and 5. So this is where it's more, 2 or more. So at least 2, so that means 2 or more. So we're going to deal with just those. Okay. So when we deal with that, what we're going to do is we're going to go ahead and figure out what's going on here. So we can go ahead and put in these numbers really quickly. Hopefully you can do those in the calculator really fast and everything. And I believe I already did that part. Let's see. And so here, just rewrote that again. So here, these are your numbers in front. So the coefficient of the first one is 1, that's 5, 10, 10, 5, and 1. Then these here. All right, so what we're going to deal with is just these numbers right here. So I'm going to write those down really quickly. And I'm going to write these out horizontally, like in a straight line there. And put our addition signs in there. Going to put our addition signs there. And just like before, you can get rid of the anything that has a 0 power. So I'm going to get rid of that s to 0 power. And so when we're writing it horizontally, you can take that part out. You can take the 1 out also, the 1's out. So for that last one, I'm going to take that out. Okay, and so here's what we're looking at. Oh, come on up. There we go. So here's what we're looking at. Ooh. And let's pull this in over here also. So here we have all of this there. Okay. And so now I want you to write that out. And I'm going to tell you what we're going to do next, because they gave us something else in the problem that's very vital for this last part. Okay, so everybody should have that down, hopefully. All right, now, in the problem, they gave us one last information that we haven't dealt with yet. One last bit of information. And that is the survival rate is 90% if cared for properly. 90% is cared for properly. So if our survival rate is 90%, what would be our dying rate? Okay, so hopefully you realize that that's 10% there. Now, I'm not going to go there. I'm not going to go on that side. So here, let me go and go back to my Elmo. And let me make this big. So we're done with the problem part that we need. So the actual words part. We don't need the words part anymore. All right, so before we actually do all of this stuff here, our survival rate is 90%. Okay. Now, if that's our survival rate, what would the dying rate be? And like we said already, it's 10%, because we only can have 100% of something. So if 90% of it means it's going to be a survival rate, that means only 10% of its dying rate. So let's change these to the decimal. And again, this survival rate is in the problem. And what I want you guys to do is not quit because it's a word problem. I need you to persevere through this, guys, because you're too smart to be giving up on me. Don't give up. Okay, so all we're going to do now is, now that we have a survival rate and a dying rate, and here we know again, S is for survival, D is for dying. So what we're going to do is substitute these values of survival into the S parts, and we're going to substitute 0.1 in for the dying parts. So let's do that really quickly. So, oops, sorry. Let's keep this in pencil. Let's do the S. Let's do the S parts in red, so we can see there's a difference. And then let's put our D's in blue. And then again, I'm going to write down these parts here in pencil so that we can see there's a difference. All right, so at this point, hopefully everybody sees all we did was substitute the values in. So we took these parts here, we substituted it into the problem. Okay, and all you do now is just put that in the calculator exactly as it is, and we'll figure out what's going on. Exactly as it is. All right, so giving you some time to put it in. All right, so you should get about approximately 0.0815. I think that's the approximate. I don't think it's exact. Okay, so we're going to change that from a percent to a decimal to a percent, sorry. So it means we need to move it over 2 places, so we get that percent. So we get about 8.15%. Not 2 decimals, 1 decimal. That's approximately 8.15%. And then again, write that in the sentence so that makes sense, so it's not just a number. So the probability that at least 2 trees die is 8.15%. Okay, and that's it.